Introduction. Today we learn isomers and concepts used in organic reaction mechanism. Anybody knows about isomers? Anyone? No? Okay, I will tell you. The organic compounds which have same molecular formula but different configurations are called isomers. The examples of isomers are dimethyl ether and ethanol. They have same molecular formula but different configuration.
Teacher, what is reaction mechanism?
Reaction mechanism is a sequence of steps during which chemical reactions occur. In this lesson, you will learn isomers and fundamental concepts in organic reaction mechanisms. Objectives. At the end of this lesson, you will be able to describe isomerism and its types, explain fundamental concepts in organic reaction mechanism. Isomerism. Existence of sets of two or more compounds with same molecular formulas but different configurations and hence different properties. The compounds are called isomers. Different types of isomerisms are: isomerism can be grouped into structural and stereoisomerism. Structural isomerism can be subdivided into chain isomerism, position isomerism, functional isomerism, meta-isomerism. Stereoisomerism further categorized into geometrical and optical isomerism. Structural isomerism. Structural isomers are the molecules which have the same molecular formula but have different arrangement of atoms. Chain isomerism. Chain isomers have same molecular formula but have different order in which carbon atoms are bonded to each other. Structural isomerism. Position isomerism. This isomerism is due to the difference in the position of functional group in the same chain, is termed as position isomerism. Functional group isomerism. They have same molecular formula but different functional groups. Metamerism. This isomerism arises due to non-uniform distribution of carbon atoms on either side of functional group. For example, methyl propyl ether and diethyl ether. Stereoisomerism. Stereoisomers have the same molecular formula and same connectivity, but different orientations of their atoms in space. Stereoisomerism can be grouped into geometrical and optical isomerism. Fundamental concepts in organic reaction mechanism. Organic reactions are chemical reactions involving organic compounds. The organic molecule is also termed as substrate, reacts with attacking reagent and forms intermediate and then the final product. A reaction mechanism is the step-by-step sequence of elementary reactions by which overall chemical change occurs. Fission of a covalent bond. A covalent bond may be broken by two ways: heterolytic cleavage, homolytic cleavage. In heterolytic cleavage, the bonding pair of electrons remains with one of the two fragments between which the bond is broken. For example, all carbocations have a positive charge on the carbon atom. Classification of carbocation. Primary carbocations. In this, the carbon atom which carries positive charge is attached to only one alkyl group. These are also called 1-degree carbocation. Secondary carbocations. In this, the carbon atom which carries positive charge is attached to two alkyl groups. These are also called 2-degree carbocation. Tertiary carbocations. In this, the carbon atom which carries positive charge is attached to three alkyl groups. These are also called 3-degree carbocation. order of stability of carbocations is: a carbanion is negatively charged molecule that induces a carbon atom with negative charge. The simplest carbanion is the methide ion, can be derived from methane by a loss of proton. Homolytic cleavage. When a covalent bond breaks in such a way that each atom retains one electron of the bond, the process is called homolytic cleavage or homolysis. It often produces free radicals. The movement of single electron is shown by a fish hook arrow. Nucleophiles and electrophiles. The reagents which are electron-rich, such as chloride ion, are called nucleophiles because they seek centers of positive charge, that is, nucleus. Nucleophilicity can be defined as the tendency of an atom to donate electrons to an atom. The reagents which are electron deficient, such as carbocations, are referred to as electrophiles. Electrophilicity can be defined as tendency of an atom to accept electrons from an atom. Electron movement in organic reactions. Curly arrows are used to show the movement of electrons. The tail of the arrow indicates the location from where the electron pair is shifted, and the head of the arrow indicates the location on which the electron pair is moved. Movement of single electron is indicated by half-headed curved arrow. Electron displacement effects in covalent bonds. An attacking reagent can be positively or negatively charged. Therefore, the reagent will attack a substrate only when the substrate develops an opposite charge and the substrate can develop some polarity by the displacement of electrons. Such displacement of electrons in the substrate molecule is referred to electron displacement effect. Inductive effect. It is a permanent displacement of electrons which originate due to the difference in the electronegativity of the two atoms. Let us consider a chain of carbon atom in which the terminal carbon atom is joined to a chlorine atom. Chlorine is more electronegative than the carbon. Therefore, the electron pair in the covalent bond between the chlorine atom and C1 atom will be displaced towards the chlorine atom, due to which chlorine atom acquires a small negative charge and C1 acquires a small positive charge. Now C1 is slightly positively charged, so it attracts the electron pair, forming covalent bond between C1 and C2, due to which C2 acquires a small positive charge, but the charge is smaller than that on C1 because the effect is passed from C1 to C2. Similarly, C3 also acquires a small positive charge which is smaller than the charge on C2. This type of shift of electron along a carbon chain is known as the inductive effect. The symbol I is used to denote the inductive effect. The groups which are electron withdrawing, they are said to cause negative I effect, and the electron releasing groups are said to cause positive I effect.